Welcome class. Thank you for joining me for beginning 6 to 7. So this is going to be another section of this chapter where we diverge from the idea of radicals. In this section, we're going to be talking about inverse relations and inverse functions. Now, what this means is if a relation pairs element A of its domain with element B, so basically x and y, the inverse pairs B with A. So essentially what we're talking about is here if we have an x and y in the relation, those numbers would flip in its inverse. It switches all of those values. So for a concrete situation, so if the point 1, 2 was in the relation, that means 2, 1 would be in its inverse, okay? It's flipping each of those values. It's inverting those values. Now, if both the relation and its inverse happen to be functions, they are inverse functions. However, just because a relation is a function does not mean its inverse is. So I want you to begin looking at this relation right there. So in its domain, 1.2 goes to 1, 1.4 goes to 1, 1.6 goes to 2, 1.9 goes to 2 as well. So this is a function. Right? Every x, everything in the domain, goes to a single thing in the range. However, when you flip it, when you're looking at the inverse, well now that number 1, that can be going to either 1.2 or to 1.4. You don't know which one is going to at any given time. So that is what makes this not a function. So that's one thing to understand, is just because you have a function does not mean it has an inverse function. Its inverse function may just be a relation, all right? It may not be a true function. So here's another example of how do you find the inverse of a function or inverse of a relation. So we start with our data. So 0, 1, 2, 0, 3, 2, 4, 3. So we start with all of those points. And what we're going to do is we flip-flop the x's and y's. Look, now instead of the point 0, negative 1, now we have the point negative 1, 0. Instead of the point 2, 0, now we have the point 0, 2. So literally all you do to create an inverse is you flip the x and y values in that set of numbers. Now graphically, something cool happens. So please follow along right there for me. So if you look at the graphs of relation S and its inverse, okay, if you imagine putting them in the same coordinate system, okay, the same coordinate plane, notice those points actually mirror over the line y equals x. So that most basic line that we know, y equals x, when you plot inverse points, they end up creating a mirror image across that line. Okay? Now, the cool thing is, the same thing holds true even when you're dealing with equations. So most of what we're going to be doing, well, these points were effective for giving an introduction to inverse functions. The real meat of it comes from dealing with actual equations. All right? So we have two steps for finding the inverse of a function. So the first thing we're going to do is we're going to switch x and y in the equation itself. So you notice in all those points to create the inverse, we switch the x and y's in terms of numbers. Well, now we can do it with those variables too. Once we've done that, now you're going to resolve that new equation for y, and that is going to be the inverse. All right, so step 1, switching x and y. So I'm going to switch this to x equals 2y plus 8. But now we want to solve it for y. We're not finished yet. So how am I going to solve this for y? Well, I'm going to subtract the 8 over. So I'm going to have x minus 8 on this side equals 2y. Then I'm going to divide everything by that 2. So I'm going to get 1 half x minus 4 equals y. Or if you're more comfortable writing the y first, feel free. Y equals 1 half x minus 4. That is going to be the inverse. Now, this time we can actually say it is the inverse function, because you know every line is actually a true function. All right? Now, to kind of get the idea of graphically what this looks like, I'm going to graph both of these lines. So, I'm going to graph this first one in blue. So, 2x plus 8. So I'm going to start 1, 2, 3, 4, 5, 6, 7, 8. I start up at my y-intercept. Now I'm going to use that slope of 2, up 2 over 1, and to get a straight line, I'm going to follow that same pattern backwards. So there is my original line, all right, my function. Now I'm going to plot my inverse function again so I can see graphically what this looks like. So start down at my y-intercept, which is down at -4. And now I have a slope of 1 half. So up 1 over 2, up 1 over 2. So again, I'm going to plot many points so I can get as accurate of a line as possible. And while the graph won't be perfect, you can see that it is a mirror image across that dotted line. And that dotted line is representing that line y equals x. All right, I want you to get that visual in your mind. When we find these inverse functions, it is basically a reflection over the line y equals x. So, find the inverse of y equals x squared minus 1, and then graph both. All right, so first things first, we have to switch the x and the y. All right, now we need to get y by itself. So I'm going to add the 1 over. So we get x plus 1 equals y squared. Now this is where it's going to get a little bit tricky for this one. All right, because you guys hopefully remember from earlier in this chapter. I remember when you square root something, when you square root either when it's telling you in words, here is something and now square root it, or remember square rooting in an equation like back in chapters 4 and 5. When you square root, you end up with a plus and minus. Now, when you get something that looks like this, you have plus and minus. Well, this actually won't be a function, okay? So this time, the inverse, we can call it a relation. Everything is a relation. But this time it's not actually a function. Because of that plus or minus, we're going to get a shape that does not pass the vertical line test. And graphing this, well, we're going to have to talk about graphing this thing too. So I'm going to start with a graph that we know, okay? Y equals x squared minus 1. So y equals x squared minus 1. Well, let's say you've forgotten how to do this. Let's just plot some points, okay? So we should know the general shape is a parabola. But let's just plot a few points to get its general shape. So I plug in -2. Well, negative 2 squared is 4, minus 1 is 3. So negative 2, 3. Plug in negative 1. Well, negative 1 squared is 1. 1 minus 1 is 0. Plug in 0. 0 squared is 0. Minus 1 is a negative 1. 1 squared is 1. Minus 1 is 0 again. And then 2 squared is 4. Minus 1 is 3. So notice we're just getting a basic parabola. And that basic parabola is just shifted down 1 unit. Okay? So now, the cool thing here is we could do that same thing. Okay? We could plot points for the inverse. However, because we haven't really talked about how to plot that type of inverse yet, there is a different way you could go about graphing it. Because for the inverse, didn't we say that all you're doing for an inverse is you're flipping each of these values? Oh, sorry, didn't expect it to do that. So that is one cool thing, is because we haven't really talked about how to graph square roots, you know that for an inverse, all it's doing is flipping the x and y values. So I'm going to construct a second table, now looking at those values to plot and graph. So 3, negative 2, 0, negative 1, oh, I'm sorry, I misplotted that. Oh wait, no, sorry, negative 1, 0, 0, 1, and 3, 2. All right, so even though, again, I didn't really plot it properly. Usually we like to look at the equation to plot it. But again, because we haven't really talked about how to graph a square root equation, I used my knowledge of inverses in order to graph it. Okay, because inverses say you switch x and y's, so that's how I obtained the data on the inverse relation. And notice, I keep using the word relation because it does not pass the vertical line test. That red one, that y equals plus or minus square root of x plus 1, that is not a true function. It is simply a relation. All right, now that is all the notes that I actually have for you today. So please make sure you have all this written down, the graphs plotted, and then we will do our practice work in class.